Okay, this is the video for lessons 7.5 and 7.6. We're going to combine those two into this one video. And in our previous video, we were learning about special right triangles, the 45, 45, 90 triangle, as well as the 30, 60, 90 triangle. And we had some special formulas that we were using to find the different lengths of the sides. And in this video, we're going to continue working with right triangles, but we are going to introduce the trig ratios. Now, these ratios can be used in right triangles that do not have angles of 45, 45, 90 or angles of 30, 60, 90. So, of course, there are right triangles that don't have those angles in them, and so these are the ones that we're going to be using. This tangent ratio, the sine ratio, and the cosine ratio are going to help us in order to find different lengths and different angles, and so we need to start introducing these in this video. So go ahead and write the first vocabulary definition. A trigonometric ratio is a ratio of the lengths of two sides in a right triangle. So again, it has to be inside of a right triangle that when you use the trig ratios. The ratio of the lengths of the legs, the two legs, remember we have special names for the sides of right triangles. Every right triangle has two legs, and then of course it has the hypotenuse, the longest side or the side opposite from the right angle. So this ratio is called the tangent of the angle. So the tangent of the angle is basically it's just a fraction that we create out of the lengths of the legs in the right triangle. We also have a ratio for the sine and the cosine, and these are trig ratios for acute angles that involve the lengths of one of the legs and the hypotenuse. So we're going to go ahead and write down these three ratios that we're going to be using in this lesson. So the tangent ratio is going to be the opposite side from the angle that we're talking about. That's going to go on the top of the fraction. The adjacent side is going to go in the denominator. Okay, so when we're dealing with a right triangle, like let's just say this one, and we have A, B, and C. C is going to be our right angle here. If I want to know the tangent ratio, let's just suppose that I want to know the tangent of B. Well, if I'm standing at B, which side from me is opposite? That would be AC, right? AC would have a length. Let's just say that it's 6. And the opposite side over the adjacent side, let's say it's 4. The adjacent side is the one that's right next to where I'm standing. So this ratio would happen to be 6 over 4. Okay, so you just have to be able to identify which side of the right triangle is opposite and which side of the right triangle is adjacent, and that's our tangent ratio. The next one that we're going to look at is the sine ratio. The sine ratio is the opposite side from the angle you're talking about over the hypotenuse. Now we can usually identify the hypotenuse pretty easily because it's the longest one. So let's go ahead and draw a right triangle. Here's A, here's B, and here's C. So which side here is the hypotenuse? Yes, that's this one here. Now if I'm standing at angle A, because I want to know what the sine ratio of angle A is, I have to look for the opposite side. That's this side right here. It's opposite from where I'm standing. And let's just say that that side is 3 and that our hypotenuse is 5. Then that means the opposite side is 3, which goes on top here, and the hypotenuse is 5. So again, the hard part is just identifying which side is opposite, and then of course putting that over the hypotenuse. Okay, and then the last ratio that we're going to do is the cosine ratio. That's going to be the adjacent side over the hypotenuse. Now if you go back to the definitions up at the top of your page, it says the sine and the cosine ratios are trig ratios for acute angles that involve a leg and the hypotenuse. So if you notice, the opposite side is a leg and the hypotenuse is part of the sine ratio, and the cosine ratio has the adjacent leg over the hypotenuse. Okay, so if I draw another right triangle here, let's go ahead and put this together. We have A, B, and C. So this is a right triangle. We don't know what the angle measures are other than that C is angle, the angle C is 90 degrees. Let's just suppose that I am standing at angle B. That's the angle that I want to know the cosine of. Which side is adjacent to where I am? The side that's adjacent to me is BC. It's right next to me. And let's say that one has a measure of 4. And then the hypotenuse, of course, is the one that's across from the right angle. Let's say it's 7. So now we have the adjacent side over the hypotenuse, and that's really all we have to do. So because this is not a lot of information, I'm going to go ahead and combine this with lesson 7.6. So let's go ahead and get started on a couple of our example problems here. You will need a calculator because I'm going to ask you to do two things. One, write your answer as a fraction, and second, write your answer as a decimal, rounded to 4 places. Okay, so we're going to need to remember that. Now, this one is asking us to find the tangent of x and the tangent of y. Let me just give you a little hint on how to remember all of these ratios. So this is not something that I've made up, but in any trigonometric video or lesson that you're going to be looking at if you happen to go online, you're going to see this abbreviation, so, ka, toa. Okay, so that seems a little bit strange, but if you go back up to what we were looking at, the T, let me see if I can do a highlighter situation for you. Let's see. The T right here, and the O, and the A, that's what this part is. That's the TOA part. So tangent is opposite over adjacent. And the sine, here's the S, and we have an O, and we have an H. That's the SOA. I'm sorry, SO, S-O-H. And then, of course, we have the cosine, that's C-A-H. That's our ka. So, ka, toa is just supposed to be a helpful way to remember which parts of the triangle go with which when we're looking at the ratios. So if I'm looking for the tangent of x, all I'm doing is looking for the two sides that represent the opposite and the adjacent. Okay, so now here's what I want to do. I want to put myself in the position of being at angle x, and I want to look across the triangle and look for the opposite side. I'm opposite from the x. That's going to be 13. That goes on top. And then the adjacent side goes on the bottom. Now, how did I know that's the adjacent side and not 85? Because 85 is recognizable as the hypotenuse. This length is the hypotenuse. It's the longest side and it's opposite from Z, our right angle. So we not only did we have to write it as a fraction, but we also need to get our calculators out and find the decimal equivalent to 4 places. Alright, so when I type that in, 13 divided by 84, I get 0.15476. But I only want 4 places. This 6 is going to require that I round up to 0.1548. So here's my answer. Make sure you give me 4 digits and make sure you do the correct amount of rounding there. So the next thing we're going to do is we're going to do tangent Z. Now remember, not tangent Z, tangent Y. Remember, if you are standing at the angle that they're asking you about, tangent Y is going to be over here. The tangent is the opposite side over the adjacent side. So now 84 becomes the opposite side because it's across from Y, right? So the purple one. And the number 13 becomes the adjacent side. So depending on the angle that they're asking you about, remember angle Y, the opposite side is 84. okay, if you're looking across from where you are standing. Now, if I take my calculator out, I'm going to take 84 and divide by 13. I'm going to get 6.4615. Still keep the 4 digits as part of your answer. Alright, I'm going to remind you about the sine ratio now. Sine is, remember, part of our SOHCAHTOA. We already did the TOA part. We just got done doing tangent is opposite over adjacent. And so now we are going to do the sine, which is opposite over hypotenuse. So we have to find sine x and sine y. We need to write it as a fraction and as a decimal rounded to 4 places. So basically what I'm going to do here is I'm going to identify the hypotenuse because we are going to need to use the hypotenuse in this ratio, right? H stands for hypotenuse in our abbreviation here. But the only difference is going to be which side is opposite. Well, when we're looking for sine of x and we're standing at the x, which side is opposite? That's this one over here. That's the 20. So we're going to have 20, which is opposite from x, over 52, which is the hypotenuse. And then we're going to use our calculator in just a moment to get a decimal. And then we also have the sine of y. And if I'm standing at y over here, guess which side is opposite? 48. Okay, so 48 is opposite. The hypotenuse is still the hypotenuse. And now we just need to enter this into our calculator. 20 divided by 52 gives us 0.3846 if rounded properly. And our sine of y, which is 48 divided by 52, is 0.9231. Okay, so the fraction part is the ratio, which is what we're talking about, and the decimal part is just another version of that ratio. Okay, so hopefully you're getting a pretty good view of what these ratios are, and we're going to now do the cosine, and we abbreviate the cosine with just COS. So remember that it's spelled like this, so please pronounce it correctly when you say the word. So in our abbreviation, CAH is what we're doing in this problem here. CAH stands for cosine is the adjacent over the hypotenuse. So let's go ahead and identify cosine P. We're going to be at P, and we're looking for the adjacent side to P, the side that is nearest to P. And of course this is our hypotenuse because it's opposite the right angle. So when I write out my ratio, it's going to be cosine of P equals 72, which is right next to angle P, over 97. And I'll get you the decimal equivalent in just a moment. And then when we look for cosine of Q just means that if we're at angle Q, which side is adjacent? This one is because it's really near to angle Q. So cosine of Q is equal to 65, that's the adjacent side, over 97, which is our hypotenuse. Alright, so if you put this into your calculator, 72 divided by 97 is 0.9423. And if you put in 65 divided by 97, you should get 0.6701. And that's really all you have to do to set up these ratios. The hard part, of course, for most students is to identify which side is the adjacent side and which side is the opposite side, and then of course remembering all of the ratios, and that's what that mnemonic device is to help you with. SOHCAHTOA, and that's just something that you're going to have to keep on remembering. Let's take a look at the back. On the back here we have 6 practice problems that I would like you to complete on your own, so you will need to use your calculator. I do have a couple of hints for you. Remember, the sine is the opposite over the hypotenuse, the cosine is the adjacent over the hypotenuse, And the tangent does not involve the hypotenuse. It's just the opposite side over the adjacent side. So when you're looking at numbers 1 and 2 and they're asking you to find the tangent A and the tangent B of each triangle, you will not need the hypotenuse. Okay, so you will not need that side. And if you look at number 2, you will not need the hypotenuse because you're looking for the tangent. And the tangent is just the opposite side from A, right? If you're here, which side is opposite from A and which side is adjacent. So that's what you're looking for. You don't even need to write the fraction. I just need you to write the decimal, 4 places of the decimal. And then tangent B, if you're standing here, you're going to switch those two sides because now 42 is across or opposite from where you are positioning yourself in the triangle. And that's it. Okay, so make sure you know that you're not using the hypotenuse when you're looking at the tangent ratios. Okay, 3 and 4 are sine, and so that's going to be opposite over hypotenuse, so make sure you can identify the hypotenuse in each triangle. Those are the longest sides of any triangle is the hypotenuse. And then when you look at numbers 5 and 6, you're looking for the cosine A and the cosine B. And of course, those are just the adjacent over the hypotenuse. Here's the hypotenuse, longest side. Here's the hypotenuse here, longest side. So one more reminder, if you're looking for cosine A, position yourself in the triangle at A, and remember it's going to be the adjacent side over the hypotenuse. Okay, so there's some hints for you. I hope that you do well and get the correct 4-digit decimal for each one of those. And then we are going to go ahead and start with example 4, the last example on this page. So we need to find a leg length using the tangent ratio. So it looks like to me we have a side of the triangle that we do not know, but we do know this angle. Alright, so if we know this angle and it is a right triangle, we can use the tangent ratio to find out what the length of that leg is. So here we are, and tangent just means opposite over adjacent. Okay, now this is a totally different kind of problem, so we're going to need to set up a proportion, and in this case we're going to say, okay, the tangent of 28 degrees is equal to the opposite side, which we do not know, over the adjacent side, which we do know. And now we're going to put this over the number 1, and we have a proportion set up. Okay, so now we are going to cross multiply. That's what we do with proportions. X times 1 is just x, and then 15 times the tangent of 28. So here's how we write that. 15 times the tangent of 28. Okay, so in your calculator you're going to need to type in tangent 28. So find that button that says TAN on it and type 28, and then you're going to hit the multiply button and type 15. And the result of that is just 7.97, or if you wanted to round it, you could tell me that the length of that side is 8. Okay, so because we have the angle here, and we do not know the side that's opposite, we can set up this proportion and solve for the length of that side. Alright, on the last page here we have 2 problems that are asking us to use a trig ratio to find the value of x in the diagram and then round to the nearest tenth. That's 1 decimal place. Okay, so in problem A, it looks like we are going to be solving for the hypotenuse, and it looks like we have a 29-degree angle and then another side that is 18. So the angle that we're given is where we want to position ourselves, and then we want to identify, besides the hypotenuse, which other side do we have? Well, this side is really close to us, so we're going to call that the adjacent side. Now, if you remember back to our abbreviation, which is SOH, CAH, TOA, which of the 3 trig functions should we use here? We have an adjacent side, and we need to solve for the hypotenuse. Well, that's the one that's called cosine. The cosine of 29 degrees is equal to the adjacent over the hypotenuse, which we don't know, and that's what we're trying to solve for. So we need to cross multiply. Remember, we're just going to put cosine 29 over 1, and 1 times 18 is just 18. And then cosine 29 times x is cosine 29x. So anytime we want to get x by itself, we have to divide by the cosine of 29 here, because that's the number that's sitting in front of the x. Cosine 29 is an actual number. If you type that into your calculator, you're going to get a decimal of some kind. So we're going to divide by cosine 29 on the right and on the left, and when we get done, we should have an answer and the length of our hypotenuse. So if you type that in, you should see the length of the hypotenuse is 20.6. And does that make sense for this problem? Well, absolutely, because the hypotenuse is supposed to be the longest side of the triangle, and it looks like that is the case. And we're going to try problem B now. So problem B, we have one of the angles is 42 degrees, and that's where you want to position yourself. Think about standing right next to that one, and that's going to help you figure out which sides of the triangle you have that you need to solve for or that you are given. So I have the hypotenuse because it is across from the right angle, so I know that this is the hypotenuse, but I do not have the opposite side. This is opposite from where I am, or from the angle that I was given. So remember back to our abbreviation, O and H, those are for the sine. So I'm going to do sine 42 is equal to the opposite side, which I do not know, over the hypotenuse, which I do know. And now I'm going to put this over 1, and I'm going to cross multiply. So x times 1 is just x, and now I have to cross multiply this way, and that's going to be 52 times the sine of 42. And remember, the sine of 42 is a decimal, and once you type that into your calculator and multiply it by 52, you will find the answer of the opposite side from the 42 degree angle, which is going to be 34.8. So this is the length of the opposite side over here, 34.8. And that makes sense because we do not want it to be as big as the hypotenuse. So what I would like you to do is I would like you to practice numbers 7 through 10. This may take a little while, I understand that because it's brand new, but I do want you to set up the problem. So you're going to consider the angle that you've been given. Go ahead and position yourself right there. If this is the angle they gave you, then think about where you are in the triangle. Again, over here, this is where you're standing, this is where you're standing, and then be careful because I want you to identify the sides. Do you have the hypotenuse? Are you solving for the hypotenuse? Do you need the adjacent side? Are you solving for the opposite side? And that's going to help you determine which ratio you're going to use. Is it going to be the sine, the tangent, or the cosine? And hopefully you've seen enough example problems to be able to determine which of those ratios you want to use. Alright, we have one last example, and this example is showing us how the trig ratios will work even if you have a 30, 60, 90 triangle. So here we can see that we have a 30, 60, 90 triangle, and we could just use those formulas we know about the 30, 60, 90 triangles. And if you come across a 30, 60, 90 and you like those rules better and those formulas better, feel free to answer the question based on that. Or you can use a trig ratio. In this case, it's asking us to use the tangent ratio. And so if we stand here at the 30 degree angle that they've given us here, opposite side over adjacent side is going to give us the same result as if we take the short leg and multiply by the square root of 3, which is how we find the long leg, right? This is the long leg if we're referring back to our 30, 60, 90 degree rules. So we have to do two things. We have to use the tangent rule, and that's going to be tangent of 30 degrees is going to be equal to opposite over adjacent, which we do not know what the adjacent side length is. And then on the other side of the picture, I want you to say, okay, well, the long leg is what we're solving for, and I know the short leg, and I need to multiply that by the square root of 3. So we have to do both of these to show ourselves that either way it's going to work out to the same answer. All right, let's start with our rules that we knew from the last lesson. So when I see two things under the radical, I know I can multiply those things together. So x is going to be equal to 5 root 9, because 3 times 3 is 9, but the square root of 9 is 3. So I'm going to have 5 times 3, and that's just 15. So the length of this side is 15, and let's prove that we can use the tangent rule to get the same answer. So over here I'm going to put this over 1 and cross multiply. So that's going to be 5 root 3 equals tangent 30 x. Okay, so tangent 30, remember, is a number. It's like a coefficient in front of the x. In order to solve, I'm going to have to do the division of tangent of 30 here. That cancels. We still have my x over here, but I also need to divide on the left side tangent 30. So if you type that into your calculator, make sure that you put the parentheses around this before you divide by tangent of 30. And if you do that, you're going to see that x is equal to 15. So no matter what, either way you look at this as 30, 60, 90 and use the rule, you're going to get 15, or if you use the tangent ratio and the method of finding the side using tangent of 30 there. So you have another one to practice with down at the very bottom, and please try that on your own, and then you will get a stamp for completed notes. Thank you for watching.